welcome to all to class number 90. We are nearing the end of the combination of loads of different type of loads for simple support beams. See, now earlier one class, that was class number, I noted down here, 86. I solved some identical question but less number of loads. I will tell it later, that question and this question, the difference. Okay, now question is here, draw SFD BMD for this beam. Some will tell, why such a lengthy question? No, remember, when you solve a lengthy question and understand everything, then the easy question becomes very, very simple. You directly try only simple questions. Little complication, you get difficulty. So, you start this question. First, as usual, I will start from here. Don't see here. Solution, calculation of vertical reaction. Let VAVB. This I am not telling because regular it has become. See, that one hinge, one roller or, I will take up it later. But time being not required. Even if they give one hinge, one roller, for SFD BMD, you need only vertical reactions. So, it can be hinge and roller here. But as in so many places, they always put simply support beam, hinge and roller. Simply support beam technically means like this, see, simply supported. Of course, one hinge, one roller is simply supported, correct, but technically speaking, see, simply supported this way. It cannot take horizontal load now. But if you provide a hinge here, then it can take horizontal load, but it will have no effect on SFD BMD. So that's why I am considering simple. Later, I will start putting hinge and rollers. Okay, now, moment about A as usual. I will explain again, see correctly. Don't see here. VB into 25, anti-clockwise. So, minus. Plus, now all the loads will create clockwise moment. Okay. Plus, 16 into 4 is the total load into center here, 4 by 2. Plus, 20 into 7. Plus, moment of this uniformly varying load, half into 8 into 48 into 7 plus this is 8 meter. The resultant of that load will pass here plus 2/3 of 8 plus one more is there 80 into 7 plus 2, 9, correct? 9 plus 30 into 5 is the total load into 4 plus 3, 7 plus 8, 15 plus 3, 18. 18 plus another half of 5. Written correctly? Yes. Plus 60 into 23. Why from 25 subtract 2. You get the value of VB. Sigma V0, not much required to explain. Plus VA plus VB minus 16 into 4 minus 20 minus 80 minus half into 8 into 48 minus 30 into 5 minus 60 0. You get the value of VA. Next, SFD BMD. But before going to SFD BMD, see, I will mark all the standard points here. Actually, you usually mark here. The reason is there. C, D, E, F, G, H. At the point E, where the point load is there, which is somewhere in between UVL, you need the intensity. This has been explained thoroughly in earlier 4 or 5 classes. Still, every time I explain sometimes. So, I need this intensity. Say, intensity W at E. See here. 48 by 8 into 2, so your WE will become 12 kN per meter. I entered here next time. Okay, over. Now, reactions are over. Now make a neat entry somewhere here. Neat, fresh page at the top. Enter all the values here. Okay, diagram I will draw later. Okay, first, shear force calculation. Just to understand. See here. Shear force at A. Slightly had come inside. Plus 253.56. Before that, see, you make a note at D, at E, and at H, shear force calculation twice. I am telling this one, how many times I told, I don't remember. So write it if you want. You can make out there. See, start. Shear force at A, slightly come inside. Look this side. Plus 253.56. Y means too late. Shear force at C. Whatever you got here, 253.56 minus 16 into 4. You get the answer. Shear force at D, point load is there. First, just to left of D. See, at C you got plus 189.56. After C till this point there is no load, so same value will come. But shear force just to right of D will be whatever you got just to left minus 20. You get plus 169.56. Then come to E. At E point load is there. So first shear force just to left of E means, see, just to right of D after the point load, how much you got? 169.56. Then from here till here, UVL of only base 2 meter. So minus half into 2 into this intensity is 12 kN per meter. That will give you plus 157.56. Just to right side minus 80, you get the answer. Shear force at F. Just to right of 80, you got 77.56 minus this much load. Trapezium, no problem, only load. 12 plus 48 divided by 2 into 6 will give you minus 102.44. So therefore, this question also, SF will be 0 somewhere in the UVL portion. At E you got positive, just to right. At F you got negative, somewhere in between. I wanted that way. Why? Suppose your SFD crosses the baseline under a known point or in a UDL, then you are happy because why? Easy to locate. Difficulty when the SFD will cross the baseline or zero shear force will come somewhere in the UVL. I will later tell that class number 86 and this one, what is the difference? Okay, now, what I told, okay, then next, SF at G. SF at F, whatever you got, after that no load, so copy same answer. At H, just to left. SF at G you got minus 102.44 minus 30 into 5. Okay. Just to right side, minus 60. At B, slightly come inside. Whatever you got just to right of H, after that no load, get the answer. Or look right side, same answer will come. Okay, now, little statement I have to write here. I will go for SFD now. Little statement I have to write. This I will remove. So that diagram I will draw later. This I will remove now. So little statement I will write. So that easy later. Okay. Okay, now we have to draw SFD. Before drawing SFD, you have to write variation. Sorry. SF variation. Variation. How? See, first, see, A to C and also G to H UDL. So, or first I will do one thing. I will write the variation in such a way that constant first, then linear, then parabola. So, see here. C to D, no load. F to G, no load. H to B, no load. So, SF will be constant. Okay, I'll put full constant. Constant for, or between you can write if you want. Or for means understood. For CD portion, then FG portion, and also HB portion. Okay, now, later, when I put BM variation, I will not explain SF constant you got no load, BM will be linear. Remember, later, you have to write. I will dictate here, you have to write. BM will be linear. Okay, then, SF variation will be is linear for A to C, AC portion and GH portion. Later, when you go for BM variation, UDL, parabolic second degree. I will not write, or I may write, but I will not explain once again. Okay. And lastly, SF variation all over, yes, all over. Variation is parabolic of second degree for D and C, not D to F, D to E and E to F. For DE and EF. It will not be same parabola because change will come here. Okay. Now go back and draw SFD. Draw SFD. Okay. Go back and draw SFD. I will draw the SFD first because if I draw in front of you, I will explain. What happens is because of small values, difficult to maintain that curvature or slope, then I have to keep on putting corrections. So values are here, and anyway I will tell you how to draw directly also. So I will draw the SFD, then continue. Okay, note, SFD drawn, that's very important. Now, just to understand, take your calculator and draw SFD without any calculation. See, go up by 253.56, come down by 16 into 4, you will reach 189.56. No load up to here, come parallel to baseline. Come down by 20, 169.56. From here to here, come down by half into 2 into 12, 157.56. Down by 80, 77.56. Again, come down by this much load, 12 plus 48 divided by 2 into 6. It will come to minus 102.44. No load here, parallel. Gradually come down, linearly come down by 30 into 5, 150 down, 252.44, suddenly down by 60, and then back here. This is the shearing force diagram. Okay, now, location of the point between, now you can observe. Now see, if you want, you can write. By observing shear force diagram, you can tell that SF will be 0 after E but before E. So between E and F, somewhere SF is 0. So this point you have to locate. Now, start. Let S, location of the point. Let SF be 0 at a point X between E and F at X from D. I will put a separate sketch here because I can write here. It will become a mess here. So, if after practice all you can write, because why? What is mess? If you write correctly and get the answer, no problem. But still, to understand separately, see, I will write A up to F, then cut, not required. See, this all written here now. This point you want to locate. What do you have to do? First, you need, see, W at X. So, first statement, shear force equal to at here. Let further, what is 5 is a total load. I check the shear force. Let W suffix X be intensity of UVL at X. Okay, mark here, WX. See now, 48 divided by 8, I have not written, I write here if you want. By 8, 48 by 8 into X will be the ordinate. Very careful, take X from which point? This point, where D, it's D correct? Yes. You should take X from D, not from E. Suppose you take X from E, then you get trapezium. No, to avoid confusion, see, you take X from D here. Okay, now, remember, class number 86, I will tell now only why I am telling, I have noted down here. Yes, somewhere paper I noted down, roughly, see. This way is class number 89. Now, here your SFD, then here see, it came this way, it is crossing the base time somewhere here. So, this point you want to locate, then you took X from here. That's why then at that time UVL was this way, you take X from there. Now UVL is this way, you take X from here. These all told so many times. So those who are serious, they will be laughing now. How many times he is telling it? I will tell till everybody understand. Okay, now start. To locate X, to locate X, what do you have to make? Equate shear force at X to 0. This is also known to you, 0. So, right here, shear force at X equal to, see, do one thing, shear force at here you want, look this side, plus 253.56 minus 16 into 4, I will give further shortcut for you, minus 20 minus this much UVL half into X into 6X is the UVL, not over, minus 80 equate to 0, you get the value of X. X will come in meter. I will calculate. But when I calculate, see what I am doing, who will calculate? I will see shear force here, 77.56. So 56 minus 80. It is 77.56, correct? No, I should see shear force here. that is 169.56, 169.56. After that point, minus 80, I will multiply by 2, divided by the rate of change is 6, equal to, I will take root answer, 5.4638 meter, 5.4638 meter. These all 5.46, these all tricks you will learn, not now, later, when you get the complete grip, provided all my classes you study thoroughly, left to you. Okay, now, one option, go back and enter here, how much I got? 5.4638 meter. Okay, now, immediately, substituting x value, you get intensity at x equal to, you require for BM calculation, how much? 6 into 5.4638 equal to 6 into 5.4638 equal to 32.7828. Correct? 32.7828. Sometime 32.7828 kilonewton per meter. Go back and enter here. 32.7828 kN per meter. Okay. Now, 1 minute. You need not write this much to look at the point x. Easy way is, see, if you want, you know shear force at D to just to right side, see somewhere here. After 20 is over, how much answer? 157.56. So what you can do is, you can write shear force at which point? X when you write, you can directly write, see, after this 20 kilonewton, after coming down by 20 here, see, just to right of D, what is the shear force? Plus 169.56, then minus that 80 and also minus half into x into this much load, you can see there, into 6x. 6x is the area of the triangle. Equate to 0, you get the same value of x. That is, if you understand more and as you understand more and more, you can go for all these shortcuts. Time being, you do systematically. Now, this I am not removing. Now come back and enter here. So, from the point D, your x came 5.4638 meter. Suppose somebody will ask you, what is the distance from this point E? Okay, from 5.4638, you subtract 2. Nobody will ask you. I won't write here. If you, now once you know this distance, you can get from here or from here. 1 mark is sufficient. Now, SFD is over. Now you have to go to BMD. You have to go for BM calculation. For that BM calculation, remember, this I am not removing because this you require only this much you require. This all I will remove now. This I am still maintaining because to get the BM at the point X, I will refer this diagram. Okay, I will show the BM calculation, draw the diagram, then explain. Now, BM calculation. Don't see here, you see the explanation, then go through the calculation. BM at A, 0. BM at C, look this side, plus 253.56 into 4, minus 16 into 4 into 4 by 2. These all thoroughly explained earlier, so further I can't tell. Those who are serious will understand. BM at D, look this side, plus 253.56 into 7, minus 16 into 4 is the total load into 3 plus 4 by 2. BM at E, see here, look this side, plus 253.56 into 9, minus 16 into 4 into 2 plus 3 is 5, 5 plus half of 4, minus 20 into 2, also minus half into 2 into 12 into only this much triangle, 1/3 of 2. I return the value here. BM at F, better look this side now, plus 312.44 into 10, minus 60 into 8, minus 30 into 5 into 3 plus half of 5. BM at G, plus 312.44 into 7, minus 60 into 5, minus 30 into 5 into 5 by 2. BM at H, I will not explain. BM at B equals 0. Now, I have shown all the calculation. Lastly, BM at this point, that is X point, where SF is 0, that is going to be the maximum BM. Refer this sketch. See, I'll stand here. Plus 253.56 into 4 plus 3, 7 plus another 5.4638 is 12.4638 minus, here you are doing 16 into 4 is the total load into 5.4638 plus 3 plus half of 4 minus 20 into directly 5.4638 minus 80 into 5.4638 minus 2 is 3.4638. I written somewhere. Here last I written. Lastly minus moment of this triangle load. See, only this much load is half into 5.4638 into 32.7828 into this triangle from here 1/3 of 5.4638. You got all the answer. I noted down the answer here. See, that is, I am going to rub it out now. So because when I rub the board here, I want diagram to come here. I cannot calculate once again. But I will tell you one thing if you want. None of this bending moment I wrote there, I calculate by this way. I got tricks. I got lot of tricks. See, for example, if I got SF at G and BM at G, I can find BM at F directly. What I will do is, shear force at G is minus 102.44, minus means right side is up. So that shear force into 3 and then plus the BM at G, how much I got? 1512.08. That's all. But you don't try these things all. These you try once you reach that level. So now all BM calculation over. I will draw the diagram now. I will remove this side. That will be there. This side I will remove and draw the BMD here. Okay. And lastly, one more thing. Before drawing BMD, variation you have to write. See, BM variation dictated in the class. Linear for CD and FG and HB. Parabola second degree for AC and GH. Parabola third degree for DE and EF. From E to F, it should go this way. Reach the peak value there. And one thing I forgot now, shear force diagram, see, here to here, when you start from here, 0 intensity here, 0 slope here, slope increases, again slope increases here, here maximum slope. See, this all I explained earlier. So now I will draw the bending moment diagram and close the class. Okay, I will continue. The diagram is drawn here. See, parabola second degree, linear. Again, oh, this is, yes, from here to here is parabola of third degree. This is also third degree. They are different curves. And this is linear. Parabola second degree, linear. Now see, here to here, it will go up, reach the peak value and come down. Here slope should be 0. And other things I told. Here, shear force is same both sides. Identical slope. If you have a tangent here, it should same line should continue. Same thing will happen here also. See, see, this is a parabola. This line and this tangent should coincide. This all I told earlier here. In the available space, I tried my best. Okay. This is a bending moment diagram. All are explained. Now, thoroughly practice this question. Get more grip. Next class, I will give, next class and one more class, I will give 2 plus 2, 4 practice questions where this much loading will not be there. Simple cases. But little calculations are there. As usual, practice questions. Little simple. Work out that one. Then get ready for the next part, that is SFD BMD for beams when couples are applied. Okay. We'll meet in class number 91.